ENCOR Section 6 Summary Challenge, Understanding Eigrp. Which two options are classified as link state routing protocols? Link state routing protocols are ISIS and OSPF. It actually has nothing to do with Eigrp. Eigrp is an advanced distance vector protocol. A router has learned three possible routes that could be used to reach a destination network. One route is from Eigrp and has a composite metric of 2 million something. Another route is from OSPF with a metric of 842, and the last is from RIP version 2 and has a metric of 3. Which route or routes will the router install in the routing table? Pretty simple question, actually. When the router makes a decision which route to use for a specific destination network, and we have a specific destination network here indicated, first thing it looks at is the administrative distance of the source of the routing information. A source of the routing information could be a routing protocol or maybe a static routing process. Some others too. So it will look and it will compare the administrative distances of these protocols, and these are just static values which are assigned by default, and they can be changed, but it's not really recommended to do unless you know what you are doing. So, and it happens that RIP version 2 has the administrative distance of 120 by default. OSPF has 110, and Eigrp's default administrative distance is 90. And because Eigrp has the least or lowest administrative distance, it is more preferred, and the route which is provided by this source will be installed into the routing table. Refer to the figure and the output of the show IP protocols command. Which two Eigrp metrics are being used to affect the calculation that selects the best path to add to the Eigrp routing table? Okay, let's take a look here. One thing we need to look when we talk about which metrics of Eigrp are used are the metric weight values, these K values. And they are K values from 1 to 5, and this setup here is the default one with K1 equals 1 and K3 equals 1, which means these are considered and others are not. And the first one, K1, corresponds to the bandwidth of the route, or minimal bandwidth across the whole route, and K3 corresponds to the summary delay on the route. So then the answer is bandwidth and delay, quite simply. Other parameters such as load, reliability, and MTU, which are indicated respectively by K2, K4, and K5, they are not considered because these values are zeros. Which table is used to determine the path of the packets in Eigrp? Which table is used to determine the path of the packets? I guess that's the routing table. Eigrp operates three tables, right? It has the neighbor table, where it stores information about directly connected neighbor Eigrp routers. It has the topology table, which has many kind of all possible, all learned routes. And then the best routes are installed into the routing table. So the path for the packets will be those routes which are installed in the routing table. I guess this is the correct answer. Question 5. What does the passive interface command do in Eigrp? Let's see. The router cannot form neighbor adjacencies on that interface. And this is correct answer. Unlike RIP, which doesn't establish any neighbor adjacencies, Eigrp does that, and basically when an interface is configured as passive, that means that we do not expect any Eigrp router to be connected to this interface, and essentially this hello protocol or hello communication as part of Eigrp is turned off on this interface. Let's just check other options and see why they are not correct. The router cannot send routing updates on that interface. Well, it cannot establish connections, and that's why it will not be sending updates. The router cannot receive routing updates on this interface, also incorrect for the same reason. It suppresses the exchange of hello packets between two routers, which results in the loss of their neighbor relationship, and it suppresses incoming routing packets. Okay, so this is an interesting option as well. The router cannot form neighbor adjacencies on this interface, and it suppresses the exchange of hello packets between two routers, which results in the loss of their neighbor relationship. How is this different from the first option? I'm wondering. And it suppresses incoming routing packets. To me, these two options look pretty much the same. I'm not sure if it specifically suppresses incoming routing packets. Well, it will be ignoring them, I guess. I see these two options as equal, to be honest. I do not see any particular difference between them. Suppresses the exchange of hello packets between two routers, which results in the loss of the neighbor relationship, and it suppresses incoming routing packets. Okay, so I think I will still go with option 1, and I will tell why. Because passive interface is the interface level command, right? It is applied to a specific interface, right? And this answer here specifically defines on that interface. And this is really correct, right? They cannot establish adjacencies or neighborships on that interface. However, on other interfaces, it can still have active neighbors. This one is exchange of hello packets between two routers. Which routers, how they are identified, it's not really that clear. Yeah, so I think mostly because of this specific mentioning of an interface, I will go with option number 1. Here is the show IP route command from router R1, which is load balancing to the 10.80.13.0/30 network. Okay, let's take a look. 13, this is this network, and it is load balancing across these two different ports and these two different next hop routers. We see the administrative distance of Eigrp of 90 here, and we also see exactly the same value for the metric. Okay, which means what's going on here is the equal cost load balancing. On R1, the following change was made. In which way will the Eigrp routing table be affected? Router Eigrp 10, and then we use the command of maximum paths. Okay, maximum paths. We limit the amount of paths that I think that can be established, can be put into the routing table, or maybe it can put more routes into the table, but only use one. So I think it's pretty straightforward and simple. If we issue this command, this will limit the amount of routes, which can be established in the routing table per destination. And the result of this will be will be only one route remaining in the table. I think that's what will happen. So let's see the answers. There will be no change for the route. The Eigrp topology table will indicate both routes to the network. And this is correct, I think, because both routes will continue existing in the topology table. The Eigrp routing table will have only one route, and this is also correct, I guess. Okay, the Eigrp topology table will have only one route. The Eigrp topology table will have no route. Yeah, okay, I'm not sure about this question specifically, but I guess that maximum paths, well, to me this question becomes, this command, maximum paths, what table does it affect? Does it affect the topology table? And which means only one route will be even considered in the topology table, and therefore only one route will be established in the routing table, or it will keep all possible, I think it will keep all possible alternate routes in the topology table, and it will only limit the amount of routes which are put into the routing table, which is actually this option. The Eigrp routing table will have only one route for this address. Okay, I hope so. This answer is also kind of correct, I guess. The topology table will indicate still both routes to the network. Yeah, okay, I hope this is correct. Question 7. Refer to the output of the show IP protocols command. Which statement about the router configuration is true? Okay, so what we have Eigrp configured for autonomous system 65010. We have it configured for IPv4 with default metrics. We have a router ID. I have, well, it looks pretty standard, I guess, everything. Routing for networks here is empty, which means that actually there have been no networks added into this Eigrp, which means it will not be producing and sharing routes to its neighbors, because normally networks must be listed under this section here. Let's see, the router is configured to load balance over unequal cost paths. This is incorrect because the variance, where is it? The metric variance parameter is set to 1, which means only best routes are selected, and there will be no unequal cost load balancing. The router is configured per destination and per packet load balancing. Per destination and per packet. Well, there is no load balancing, I guess. The variance is set to the default value of 1, and this is correct. Yeah, I'm not sure what is the default. I don't see any specific kind of load balancing configuration information on this output. I'm not sure what is the default load balancing mechanism. The router is configured with automatic summarization. Automatic summarization is disabled. Okay. So simple answer, the variance is 1. Which path describes an Eigrp feasible successor route? Eigrp feasible successor is a backup path. Right? So the best path is called the successor route, and feasible successor is a backup path which matches so-called feasibility condition, which means its reported distance is less than the successor's feasible distance, so like full metric. And that ensures that the backup path will not create a loop. And yeah, so, and that's what feasible successor is. In which table are the Eigrp successor routes placed? Well, they exist in topology table and they are placed into the routing table. Yeah, so eventually they end up being placed into the routing table and used for user traffic routing. Okay, let's see. Okay, I have 2 mistakes. Let me check that. Okay, there are 2 questions I got wrong, and they are question 4. Which table is used to determine the path of the packets in Eigrp? And, well, this is kind of, maybe I didn't properly understand the question. I thought that the routing table defines that because it directs packets, right? I guess what they tell here is what information, when router operates some information to select from the best route, where this information is residing, where it is, right? And it is in topology table. So I believe the topology table should be correct answer here. Okay. And next question, where I was not that sure, the one in regards to the passive interface. The router cannot form neighbor adjacencies on that interface. Apparently, this is incorrect. Correct answer then must be it suppresses the exchange of hello packets between 2 routers, which results in the loss of their neighbor relationship. And it suppresses incoming routing packets. Okay, that should be the correct answers. I will now retake the test and just verify. Okay, I was right. This is question 4 and correct answer here is topology table, because that's where the information stored on which router operates to select best path for packets. And question 5's correct answer is the last one, as I said as well. It suppresses the exchange of hello packets between 2 routers, which results in the loss of their neighbor relationship, and it suppresses incoming routing packets. Well, I don't see how this much different from the router cannot form neighbor adjacencies on this on that interface. Maybe only this last part here, that it suppresses incoming router packets. Could it be that someone would think that without neighbor relationship, router might still accept some routing information or packets with some routing information? Well, I wouldn't think this, of course, but yeah, probably this is a better definition. And more so, this definition is specifically word by word and is formulated in the course. So it suppresses the exchange of hello packets between 2 routers, which results in the loss of their neighbor relationship. And it does suppress the incoming routing packets. So then this is the correct answer because of this.